Yes, this is Karthikeyan. Welcome to my YouTube channel. We are mechanical engineers, and today we will discuss about the types of kinematic pairs. And first, we should know what is meant by kinematic pairs. As you know that the kinematic pair is nothing but it is a joint of two links that permits a relative motion, right? So number of joints, number of links are joined together to form a kinematic pair, right? It is a joint of two links that permits a relative motion. So when any two links are connected in such a way that their relative motion is completely constrained or successfully constrained, then it forms a kinematic pair. Okay, then this kinematic pair is classified into three major categories. One is nature of the relative motion, the second one is nature of the contact between links, and the third one is mechanical arrangement between links. So let us discuss one by one. In nature of the relative motions, divided into few categories. The one is sliding or prismatic pair, the second one is turning or revolute pair, the third one is screw pair and rolling pair and spherical pair and cylindrical pair, right? Whereas for nature of contact between links, divided into two category, one is lower pair, another one is higher pair. Then third one, mechanical arrangement between links, divided into two major category. One is closed or self-closed pair, another one is force closed or open pair or unclosed pair, right? So let us discuss one by one what is what. The first one is nature of relative motion between the links. Nature of relative motion between the links, already we discussed, divide into six category. One is sliding or prismatic, turning pair or screw pair or rolling pair or spherical pair or cylindrical pair. Okay, so let us discuss first one, the sliding or prismatic pair. So what is the sliding or prismatic pair? When two links, see, so this picture belongs to this category, right? So when two links have a sliding motion relative to each other, it is known as sliding or prismatic pair. The degree of freedom which is equal to 1, right? So here this is a fixed box, so let me select the different pen color. Okay, so this is the fixed board, and this one is link 2, link 1 and link 2 both are relative motion in a single direction, the horizontal direction. So that's why this is the degree of freedom which is equal to 1 for this case. Whereas the second one is turning pair, this is the turning pair, second picture turning pair. Okay, so when two elements are connected such that one element revolves around the other, then it forms the turning pair. Here two links are there, link, I mean the shaft, this is actually shaft, the shaft with collar arrangement, and this arrangement is attached with the bearing. This is the bearing, link 2 and link 1, right? So here the shaft 1 with two collars rotating in a bearing as shown in the figure, it forms a turning pair, right? See, the relative motion between link 1 and link 2 can be expressed by the single coordinate which is called as theta, right? So therefore the turning pair has a single degree of freedom which is equal to 1, right? Then so many practical examples for this case. Lathe spindle supported in the headstock, or cycle wheels turning over the axle, right? The third one is screw pair. Here the degree of freedom is also 1, screw pair. Let us discuss how the degree of freedom which is equal to 1. The picture, it seems the degree of freedom which is equal to 2, whereas the screw pair, it has only 1 degree of freedom. That let us discuss. In screw pair, one link is constrained to have a combination of turning and sliding motion relative to other link, right? See here two links are there, one is the screw pair, the second one is fixed link, right? So this is the screw link, first one, and this is two link. The relative motion between these two links are, two motions are there, one is sliding motion and another one is theta, right? But we know the definition of degree of freedom. So degree of freedom, which means So the degree of freedom, I mean, normally a fixed, I mean the rigid body possesses 6 degree of freedom, right? So one is translational motion, another one is translation. Let me select white, right? See, one is translational motion, another one is rotational motion, right? So translational motion with respect to 3 axis x, y, z, whereas rotational motion with respect to 3 axis x, y, z. So totally the rigid body possesses 6 degree of freedom, right? So now what is meant by degree of freedom of a pair? A degree of freedom of a pair is defined as the number of independent relative motion. See, the word is important, independent. The word independent is very important, right? So the number of independent relative motions, not dependent. Both translational and rotational a pair can have, right? So this is called as a degree of freedom. See here, 2 motions are there. One is sliding motion. Let me select red color. Okay. Now here 2 different type of motions are there. One is sliding and another one is theta, rotary motion, right? So the degree of freedom, which means independent relative motions. Here the sliding motion depends on theta, right? This is dependent, not independent. So only one independent motion, which is sliding motion. So the degree of freedom for screw pair, which is equal to 1. So degree of freedom which is equal to 1 for this screw pair, right? So next one is rolling pair. So rolling pair rolling pair, which means this is the rolling pair diagram, 4th one, and when one link is free to roll over the another, it forms a rolling pair. A degree of freedom which is equal to 1. Here the ball and roller bearing setup is there, so it forms a rolling pair, right? A ball and bearing forms a rolling pair, right? Then the 5th one, which is equal to spherical pair. So spherical pair, this is 5th one, 5th diagram for spherical pair. So spherical pair, it one link is constrained to swivel in or about the other fixed point, right? It is designated by the letter G normally, right? And for example, joysticks, right? So degree of freedom which is equal to 1 with respect to x, y, z axis, either may be translational or rotational. Okay. So the last one is cylindrical pair. So in a cylindrical, this is the 6th one, degree of freedom which is equal to 2, right? So two independent motions are there. One is reciprocating motion S, I mean sliding motion S, and one more theta is also we can, right? So rotational motion is also possible and sliding motion is also possible. So degree of freedom which is equal to 2 for this case, right? And these things we will discuss in our upcoming slides. Okay, thank you.